Hey everybody, today I'm doing another math problem and we are continue with differential equations, and we still doing the same section, right? We're doing 4.3 homogeneous linear equations with constant coefficient, right? And I'm going to do the steps. Okay, explain the steps real quick. That way we have an idea what we're doing. Okay, so at step 1 we consider all three cases, right? And identify what case applies. Okay. So step 1, again, we consider the three cases, but we only identified one that will apply for the problem. Okay. Case 1, we have a distinct root. Okay, which means that the root will not be the same. Okay, so that means that m1 cannot equal m2. Okay, and then the solution is going to be the general solution, or the complementary solution, is going to be C1 e to the m1 x1 plus C2 e to the m2 x2. Okay. On case 2, we have a repeated root. Repeated root, that mean that m1 will be equal to m2. Okay, so in other words, the root will be the same. Okay, so the solution for that, the general solution or the complementary solution, is going to be C1 e to the m1 x1 plus C2 times x e to the m2 x2. Okay, the only difference between case 1 and case 2 is that we have an x in between C2 and e. Okay, case 3. On case 3 we have the the conjugate complex root. Okay, the conjugate complex root, we have we will be dealing with imaginary root. Okay, now when we dealing with imaginary root, we are going to use what is called the Euler's formula. Euler's formula is e to the I theta equal cosine theta plus I sine theta. Okay, which this is going to be translated to e to the I beta x equal cosine beta x plus I sine beta x, right? And then the next piece is going to be e is equal to the negative e to the minus, I would say, e to the minus I beta x equal cosine beta x minus I sine beta x, right? Now, reason why we use this formula is because we don't want to deal with this one. Okay, y is equal to C1 e to the alpha plus I beta times x plus C2 e to the e to the alpha minus I beta times x, right? Now, so this is very complicated. If you dealing with if you're dealing with complex exponentials, becomes very complicated. So that's why to avoid this complication, we deal with trigonometric formulas that from the Euler's formula. So this is easy, okay? Easier, I would say, okay? Now, to find the complementary solution, okay, we use this formula, okay? The formula is am squared plus bm plus c equals 0 when a, v, and c are all constants, right? So now, so this is step 1. And step 2 is step 2, right? So in step 2, all we're doing in step 2 is we will find the complementary solutions, right? Okay. Then in step 2 also we we find C1 and C2, okay? Plug into, okay, plug C1 and C2 into the complementary excuse me, complementary solution. Okay, so this is step 2. Okay, when we get over here, we are done. Okay, so what we do in step 2, we find the complementary solution, right? After we've done all this process, and then we find C1 and C2 and plug C1 and C2 into the complementary solution, and then that will be our answer. Okay, so now let me erase this, and then we will do one problem, and so we can see if we can apply all this. We can apply one of these cases to solve the differential equation. Okay, so we will do one problem. And the problem that we're doing is number 37, okay? Number 37 in this book, which is the same book, okay? The same book, our first course in differential equations with Madeline application, 10th edition by Dennis G. Seal, okay? Now, let's do number 37. Okay, number 37 says the following, okay? So, In this case, we're doing something a little different. The process is the same as the last problem, okay? But we don't dealing with initial condition that involves derivative, okay? So that's only different. That's the only difference, that we don't have initial conditions that involves derivatives. So this is called number 37. Okay, says solve the given boundary value problem. Okay? So this is what we're doing. Okay? So now, number 37 is y double prime minus 10 y prime plus 25 y, right? Equals 0 at y of 0 is equal to 1 and y of 1 equals 0. Okay, so that's the problem. Now, notice that we don't have, in the initial conditions, we don't have anything involved in derivatives. That is the only difference, okay? However, the process to find the root and to identify the cases is the same thing, okay? So what I'm going to do, I'm going to use the formula to find this root, okay? So this is going to be as follows, okay? So it's going to be m squared, okay, minus 10m plus 25 equal 0, right? Now let's see if we can factor that, okay? If we factor this, we get m minus 5 times m minus 5, right? Now this is equal to 0, okay? We set m minus 5 equals 0, m is equal to 5, right? So you can call that m1. Then m minus 5 equals 0. So m is equal to 5. You can call that m2, okay? So notice that m1 and m2 are the same, okay? Are the same. What that means is that we are in case 2, okay? We are in case 2. Okay? So now, because we are in case 2, we can write the complementary solution is going to be y is equal to C1 e to the 5x plus c2 times x e to the 5x, right? Notice that I put an x over there because we are in case 2, okay? Now, I can actually do this, okay? I can actually find C1 and C2, okay? What I'm going to do, I'm going to plug in this first. I'm going to plug in that 0 first to find C1, okay? So I'm going to plug in, I'm going to use this initial condition first to find C1, okay? So I am substituting for y, I am substituting 1, okay? And I'm going to say that C1 e to the 0 to the 5 times 0 plus C2 times 0 times e to the e times e to the 5 times 0, right? E to the 5th times 0, okay? Now, what is going to happen right here? So this go to 1, right? This go to 0, okay? So I got this 1 is equal to C1, right? Because e to the 0 power is 1 times C1 is just 1, right? So C1 is equal to 1. Okay, now let's try to find C2. Okay, so how do I find C2? Now I have this, right? Now notice that I have to use these conditions, okay? So when I use that condition, it's going to be 0, okay? I am plugging in, substituting, I am replacing y, this y right here, okay? Because this is the complementary solution, okay? I am replacing y by 0, okay? And I will say that C1 is 1, right? So I plug in 1 times e to the 5 times e to the 5th times 1, okay? Plus C2 times 1 times e to the 5th times 1, right? Now, notice that this is 0 is equal to e to the 5th, okay, plus C2 plus C2 e to the 5th, right? Now, let me just rearrange this, okay? Let me just rearrange it and make it e to the 5th plus C2 e to the 5th equal 0, okay? Okay, all I did is I rearranged it. I put 0 on the other side, okay? Now, look at this. If I factor out, if I subtract e to the 5th in this side, what do I get? I get minus e to the 5th minus e to the 5th, okay? Then I get, let me just rewrite this, okay? C2 e to the 5th equal negative, okay, equal negative e to the 5th, right? Now, let me divide by e to the fifth on both sides. Okay? Sorry about that. E to the fifth. Okay? So this e to the fifth cancel out, and those cancel out, which is equal to 1. Okay? So that means that C2 is negative 1, I'm sorry. C2 is equal to negative 1, okay? So C2 is equal to negative 1. Okay, now that I have a C2 is equal to negative 1, I am going to just write the final solution, okay? So what is going to be the final solution? The final solution is going to be y equal, let me just write this, C1 is equal to 1, right? So C1 is equal to 1, C2 is equal to negative 1, okay? So they can have more room to write the final answer. So the final answer is going to be the values from C1, and C2, substituting the value of C1 and C2 in this equation, okay? So this is going to be y is equal to C1 is 1, right? Times e to the fifth x plus negative is negative x, negative 1 times x times e to the 5x, okay, which is equal to y is equal to e to the fifth x minus x e to the fifth x. Okay? That's it. That is the final answer for that problem. Okay? Okay, that's it. Again, the only difference when we had to solve this boundary value problem is that we didn't have a derivative. We didn't have any initial condition that involved derivative. Okay, so but the steps are the same to find the root, to find the complementary solutions. The steps are the same as the problem that we did last time. That was initial value problem. Okay, so I hope this helped, and I see you in the next video.